This video was developed by Asian Institute of Technology in collaboration with Nonthaburi Municipality for the Global Faecal Sludge E-Learning Alliance. During this video, you will see the synergy between the sand beds and anaerobic digestion mechanisms for the treatment of fecal sludge. We will go through a case study, its location, technology description, components, operation and performance. In Thailand, few fecal sludge treatment plants are operating properly. This case study will guide you through the fecal sludge treatment plant of Nonthaburi City. This is an example of good practices and governmental commitment towards better sanitation. Nonthaburi Municipality is in the center region of Thailand. It is a part of the metropolitan area. It has one fecal sludge treatment plant located at Nonthaburi City Center, which is operated by the local government. The treatment plant technology is based on anaerobic digestion and sand beds with maximum capacity of 40 cubic meters. It currently operates at 75% of its maximum capacity, serving 8,000 households per year. The fecal sludge treatment process in Nonthaburi has 4 steps. The first step is the discharge of fecal sludge from the vacuum trucks to the anaerobic tank. The second step is to pass the fecal sludge to the sand bed. In the third step, the leachate from the sand bed is collected into the storage pond. In the fourth step, the dried sludge from the sand bed is scrapped for fertilizer purpose. An anaerobic tank consists of a reinforced concrete rectangular tank of 4 meters wide, 5 meters long, and 2.5 meters high. Each tank can accommodate 40 cubic meters of fecal sludge. Nonthaburi treatment plant has 31 anaerobic tanks. One tank is used for 1 day, which is sealed for 28 days in anaerobic conditions. Garbage like tissue paper, condoms, pads, diapers, grit, and other are removed by using aluminum screen. When the tank is full, effective microorganisms are added to the tank in a ratio of 1 to 200. Effective microorganisms are prepared with molasses to increase the fermentation process in the tank. Each tank has an aluminum cover to seal and keep the anaerobic environment. The tank also has an exhaust pipe and a maintenance cover. Step 2. Sand bed. After keeping the fecal sludge in anaerobic digestion tank for 28 days, it is released to the sand bed. Sand beds are shallow filters of 5 meters long, 4 meters wide, and 1.2 meters high. Each sand bed has a volume of about 13 cubic meters. Its floor is made up of concrete with 3% slope, and the filter is filled with stone, gravel, and a plastic mesh on top. At the bottom, a drain system collects the leachate and pumps it to the next step. The solid part on top gets dried by sunlight due to evaporation. In Nonthaburi, the fecal sludge is kept on sand beds from 7 to 15 days, depending on the sludge moisture and weather condition. In case of rain, to avoid increasing moisture of the sludge, mobile roofs are available. Step 3. Reservoir. The leachate from sand beds is disposed in the reservoir. An oval pond of 31 meters long, 11 meters wide, and 1.3 meters deep with a capacity of 443 cubic meters. The effluent is collected in the pond to use as liquid fertilizer in the gardens of the treatment plant. Step 4. Fertilizer storage. The dried sludge collected from the sand beds is placed on the floor and allowing drying for 7 more days. When the sludge has moisture between 5 to 10%, it is mixed and transferred to the fertilizer storage for packing. The end product is the Nakhon Non fertilizer number 2. Now the fertilizer is ready for distribution. Treatment plant performance. Liquid fertilizer. Solid and liquid fertilizers are regularly tested for physico-chemical and microbiological parameters. The pH of the liquid fertilizer at the effluent of sand bed is in the range of 7 to 8, meeting the standards of industrial wastewater. Temperature is slightly the same. As the solids are separate by filtration, the color change from black at the influent to the brown at the effluent. The removal efficiency of oil and grease is 82%. However, the concentration in effluent is 3 times higher than the standards. In terms of organic content, the biological oxygen demand (BOD) and chemical oxygen demand (COD) decrease from influent to effluent. The removal efficiency for BOD is over 88%, while the COD is more than 96%. Similarly, the total suspended solids removal efficiency is 97%. However, the concentration of total suspended solids, BOD and COD, are higher than the permissible limit, not allowing releasing to channels. Therefore, it is used as a liquid fertilizer for treatment plant gardens. Bacteria removal efficiency in the system is about 3 log for total coliforms, fecal coliforms and E. coli. The number of potential pathogens is 1,000 times smaller at the effluent. Solid fertilizer is also tested. Heavy metals concentrations in solid fertilizer are very low in comparison with the set standards for organic fertilizer. Low concentration of heavy metals is due to the fact that the treatment plant only accepts domestic fecal sludge, which normally contain very low concentrations of heavy metals. The fertilizer produced in Nonthaburi fecal sludge treatment plant is valuable due to its high concentration in nutrients vital for plant growth. Concentration of total nitrogen, phosphorus, organic carbon and organic matter is higher than organic fertilizer standards set by the Department of Agriculture, although the concentration of potassium is low. Nonthaburi municipality is committed to increase the value of its fertilizer and the treatment plant performance and coverage. The key factor of success of this treatment plant are active participation of the local government, budget support and advocacy campaigns, appropriate operation and maintenance, low energy consumption, and only domestic fecal sludge is treated to ensure the low concentration of heavy metals in the fertilizer. Nonthaburi fecal sludge treatment plant is contributing to reduce the digestive system related diseases in the municipality, which ultimately brings safe hygiene to the community. Thank you.